Um,
All right.
okay. So your first question was like, what are the terms at the end of pass connect? Let's see. I'll just pull up lifecycle.hoon here. Like this one here on the screen,
Yep.
right? This pass bind. Okay. So you correctly said the first part is the wire, which we do end up listening here. It's not necessary. You need to handle that, otherwise it like chokes and throws an error because the default behavior of on Arvo is to throw an error if something unexpected comes. So
Okay.
you do need to handle that in order to confirm the connect. But other than that, it's really just there to show us doing it. And normally you would probably just like change the default behavior to be like, all right, just keep going. Um, and then you said correctly again that like this part I'm highlighting here is the URL, so it means on this ship, and then it's going to listen on slash or fast lifecycle.
Mm-hmm.
And you're asking what the term at the end is.
Yes.
And the reason the term at the end is necessary is because these two things are like logically separate. So this could just be like blobbity boo.
And we're
Okay, so
refer
what I
to it. Okay.
and so that would mean that I would, if I entered this in my URL box, then it means whatever comes in on blobbity boo, send it as a poke to the lifecycle agent.
Okay. Okay.
Okay, so this is like a completely arbitrary name, and actually and it's not actually one of those cases where it's arbitrary, but you always end up using the same name. It's extremely common for it to be like both arbitrary and it's a different name. So just to make that concrete, I have like my implementation of the chat admin app here that I've just been doing a little bit of stuff on, and I have like a view for it, which is it's like a Gall agent that only handles like sending out JSON and having JSON come in from the front end, and
Mm-hmm.
then kind of proxies all of that to everything I do on the back end. And and this is pretty common. It serves the app under like directory picky, but that if you like hit this like picky endpoint, it then proxies or this is a file server action, so it's slightly different. But under the hood, it's using air. It's saying to serve this directory like picky view, and this thing back here, it's like very common for whatever reason for you to want to like maybe have the logical name of the app be here, but then maybe some agent that like handles proxying requests to your core app and is like lifecycle helper or lifecycle view or something like that.
Okay.
So okay, so this kind of the thing that's non-arbitrary is this name lifecycle, because you want to make sure that when something comes in, an HTML HTTP request comes in on this arbitrary name here, that it goes to the place you intend.
Okay.
And goes to the place you intend means okay, you've implemented some like handling and on poke for when some HTTP request comes in there.
Mm-hmm. Mm-hmm.
Okay.
That makes sense. Okay.
Okay, and I think I have like another uh wait, where's that one? Oh yeah, cool. So this is like our kind of coming lesson that has implementation. So in fact, here I make two different endpoints that both go to my agent called Mars. Okay, so there's two different ones, and actually, what I
Yeah.
end up doing is I end up like, so I write some on. We won't go into the details for this lesson, but I write some on poke logic that says if the mark is like handle HTTP request, I parse the URL and see whether it's coming, which one it's coming in on, and then do different things based on that. But
Yeah.
main point is that the main point to keep in mind for now is that with this last term, I tell it when something comes in here where to direct the incoming like poke, and then I write, and then inside that agent, which here happens to be like the same one, which is usually the case, I go ahead and handle the poke and do various stuff with it.
I follow now. Okay. That makes perfect
Okay,
sense.
cool. So that's there. Are state names arbitrary? Answer is basically yes.
Okay.
Everything about state is completely arbitrary, and I could. This one still uses the old version state thing. I actually want to go ahead and change that right now, like as we go through like each of these lessons, for the reasons that we saw last time, where using like this form can kind of like get you into trouble a bit.
And
Um,
and that was my other question. Can you? I'm sorry. I
No,
I
it's
did
fine, man.
not pick up that information sufficiently, but can you remind me what was the trouble that we got from that?
Yes. So the trouble that we got from it specifically comes when you like return something, your final like kind of product in
Mm-hmm.
onload. Okay? And the problem isn't that it breaks if you use version state in your TIS bar. The problem is actually that it doesn't break. Okay? And what I mean, and I'll go, let me just open up let me
Blowing my
open up
mind.
lifecycle. That's, no. I mean, this is really common in like any kind of typed system,
Okay.
which is that like you could do things to make the type system swallow various errors and give you less information, but by being more precise about kind of what you want, let me. I want to find like an example here. Probably it's best if I actually just open up something like Chat Store, since that's what you were working on. Okay, so they let me just find their part, but they use basically this exact style here,
Mm-hmm.
right?
Mm-hmm.
So you can make the type system swallow lots of errors, but then it just essentially doesn't like help you as much, right? So by having the type here, if we pinned it as like a version state, what would happen then is that um, our state variable would be of type version state, and anything that we produced in onload, any product we produced that was like of type version state would nest correctly, and it would be fine. And so the problem there is that it won't throw errors if we kind of don't. Essentially, what we want our onload to do is at the end of onload, we should always be, no matter where we started, whether we started in like send 0, send 1, send 2, send 3,
Mm-hmm.
we always want to be in a consistent version of the newest state.
Yeah. Okay. All right.
Okay.
That tracks.
And so, right. And so that's the cleanest way to say it, I think, is to say it in terms of like the goal. So the goal of onload is to put us in a consistent version of the newest state, regardless of where we start from. And when I say where we start from, 0, 1, send 2, send 3, what have you.
Mm-hmm. Mm-hmm.
Okay, so if that's the goal, we want to make sure that our like type kind of goes with that goal so that the compiler can tell us if we're, not hitting it. And if we do version state, it's just going to be totally fine if like let's say, maybe we from send 3, we get it into the right state 4 position, but from send 1 to 0 we don't.
And the thinking as to why we can update that before onload actually runs, like in our code, is because the old Gall application does the on-save packaging, and then
Mhm.
as the new one is compiled, the first thing that it does is it runs that old state through onload, and the product of that is then evaluated against the type that's declared. Is that right?
Yes, that's correct. So
Okay.
onload runs before anything else. You're right. Otherwise, it feels like you're in this like weird intermediate state.
Right.
But it's explicitly set up so that you can safely do that transition. And one way of thinking of that is that um, how would I say it? You can you can go ahead and just make a version of like this whole agent with like a bunt value,
Okay.
right? Like so. And another actually that's maybe even a cleaner way. Like let me think of like the cleanest way to say that. If I just say, like, let's do this from the perspective of I'm Gall, okay, and I'm running multiple agents and keeping track of them, and in fact I'm storing each like bundle of code, like each agent core.
Right.
I'm storing each agent core and then running it. So let's actually think of what Gall does. If I like, let's say I package up this state, or not even package up, I even like call and then store it as like probably a temporary face, right?
Right.
Right, so that's gonna track. And then I say, as my kind of the next thing I do is I call this like chatstore.hoon, and I say, okay, go ahead and give me kind of sort of the default version of this agent. um like none of these things, this is actually kind of cool to think about. None of these things have constructors. And so actually, Rizrook asked me this in the chat that doesn't exist.
Mm.
Um, but remember when he asked like, what's the difference between like objects
Yes.
and
Yes.
and this? And I said like, after I kind of thought about it, like one big difference is that um, Hoon doesn't have support for like kind of constructors as a first class thing. It doesn't have like every if you want to have constructor type behavior, you kind of have to make it by convention. Whereas I don't know, have you ever done anything in like Java or C++ or Python or one of those?
Very, very little.
So all I'll say is that the way you're thinking about Gall apps right now is actually the way that like Java, C++, and Python all handle this situation, which is that they make this like you you make your like class, has some similarities to a core, and it has this kind of thing called a constructor, which is kind of a magical thing that the surrounding environment will always call whenever you make a new version of your object. And you can
Okay.
pass arguments into it, and it'll like do all the stuff to get it into a consistent state. But the key thing is that it's like a magical thing that is always called.
It's
In
like a function
fact,
in VBA. Like VBA is the
absolutely
language I'm the
yes.
most familiar with. So yeah. Okay.
I actually could. I think it's actually worth like just looking at like in a like.
Yeah.
I'm just like gonna Google something random, just some shitty um, tutorial. So do they have? I just want to see if I can find like yeah, new class name lamb, how to access members. Or, let me see if they have just constructor. If I go down, okay. Mhm, mhm. Oh wait, crap. Okay, let's actually I want to find this, so I'm gonna take a second because I just want to show the magic aspect. Java constructor examples. Because just Java is like so it's like very clean and clear in this regard. Okay, great. So the Java kind of rough equivalent of a core is a class. And it has actually a lot of similarities to a core, and the way that they work is actually kind of similar for your current and slightly maybe incorrect model of a core. So you declare a class, it's named my class here, and you give it this member variable, which is loosely analogous to like us declaring,
Right.
types here,
Right.
right? And I think you've seen versions of this probably in
Yeah.
VBA or similar, right? Like you declare a class, you declare that it has these variables.
Yep.
Then you make this magic thing called a constructor, okay? And what's magic about it is that it has the exact same name. This is not by convention. This is you have to have this as part of the language.
Hmm.
It has the exact same name as the class, and it's a function. You could pass like arguments to it.
Yep.
Okay. Here we make it so that it doesn't have them, and it just always sets x to be 5. And then when we go out here and we say, give me a new thing of my class, that's the trigger for Java to run the constructor along with any arguments that we pass, which here are not.
And we could have some internal to the constructor, some logic where if arguments came in, it would make X 4 or 7 or whatever.
Absolutely,
Yep. Okay.
absolutely, and you could have multiple variables there you assign. You can have an arbitrary number of
Yeah,
arguments,
it's a
etc.
function. Okay, that tracks
Exactly.
completely.
It's a function, and the key thing is that it's kind of magical, in that like it's there's no convention here. This is like how the language works.
I wonder why I
When
have this perception of how this stuff should work, since I really don't have that much programming experience.
Yeah, it's maybe it's just something that's like kind of so intuitive, like this idea that you like make something and then initialize it, that like it's kind of this like shelling point where like
Yeah.
implementations of object-oriented languages go here because it feels really natural. That could well be the answer. So, long story short, Hoon doesn't have any support for anything like that. Okay,
Okay.
so if you go to Hoon and and Gall says, all right, basically compile this whole thing and then give me the core that it evaluates to. At the end of all of this evaluation, the thing that it evaluates to is this door. Okay, like all
Hmm.
of this stuff creates various like it sort of sets up the subject.
Yep.
Right. So first we essentially like I didn't actually talk about this. Like Waterparter had this in his like pretty good rote documented tutorial where he kind of did a thing. I'm gonna just because this lesson today is like pretty easy. I'm kind of gonna go off on these tangents a little
Yeah.
bit. Um, And so what he notes here, I want to find I'll find the exact part because he like oh, 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 yeah, yeah. So he says right here, like, before we move on, I want to clear up one thing that confused me. We just defined a core, and like hep hep terminated the expression. But now we're going to add another expression below, which will reference the core we defined above. Normally, we'd have to explicitly compose the expressions with a tiscar,
Yeah, right.
right? Like, if
Okay.
you were doing this in the dojo, you can't just type expressions and have stuff happen, right?
Right.
Right? But as it turns out, Hoon files built by Ford, and Gall is able to like use Ford to build them.
Right.
This extra vein are parsed as a list of expressions which are implicitly composed, meaning that they kind of like Ford inserts tisgars between all of them.
Oh,
Okay, so
that's
what he says
weird.
is like he's like, yeah, it's just it is what it is, and I'll show how he's like here I'll prove it. And so he actually this is no longer commented. He just writes like dot 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 dot.
Yeah.
So composing dot with anything is a no op, right? And we can, go ahead and if we
What
want to like,
exactly does no op mean?
no op means it like doesn't do anything.
Oh, okay.
So yeah, so that just works here. So this is like notice what he means is that this is doing like tiscar dot dot is the same as just doing dot.
Okay. Okay.
I think you'll be able to track pretty clearly if I do like this.
Yeah.
So I'm
Same.
just I'm
Same
just
thing.
I'm just I'm just chaining them all together, and each time it's doing this. No op is like basically it's like adding zero to any number or multiplying a number by one.
Yeah.
Right?
Okay.
It's like an operation you can do that doesn't do it. The identity operation. Okay? So he goes, so he's like, it's a no op, so we can do it as many times as we want. But he's like, if you try to just enter dot dot in the dojo, like that's not kosher. It won't even let me do
And there's a
it. Okay?
differentiator between the Ford composition and the composition from the dojo. Is that what?
Correct,
Okay.
correct. So basically, and the reason there's a difference is dojo is like its own program, and Ford is like explicitly called by Gall to like so basically Arvo gives Gall access to Ford compilation, and it has its own like a couple special runes that we've seen a lot already, and we're going to go into today, and some extra rules.
Okay.
Okay, and I want to see if he. Oh yeah, he's actually interestingly here. Well, we can talk about that briefly, but he's using some old runes here that no longer are supported, and actually his program then broke once they did the Ford Fusion
Good
update.
times.
Yeah, no, it sucked a bit, and it kind of brought up the need for eventually we're gonna have to figure out how to handle third-party apps when there's breaking changes
Yeah.
in an OTA update because it would left him he probably just ended up, deleting the program internally or something, or making the changes himself and then doing the OTA. But it's non-trivial. Um, so going back to where I'm trying to think where we were. Oh, right. So we go here, and so for when Gall evaluates this file using Ford, actually, as we'll talk about today. So it's really apropos. It first evaluates this core.
Hmm.
So now it basically has a core in the subject. Then it goes ahead and it makes a new subject by pinning a state 3 to it with a bunt value of state 3, right?
Hmm. Hmm.
Then it says, we're just going to do this like,
Alias it.
this alias it where state is the head of that. And then, okay, so in each of these, we're actually just like doing operations and like just composing them all together. Although this is more normal because this still like these are still one operation and it's expecting a tail, right? So
Right.
it's not as weird as just writing a core without tiscar,
Yeah.
right?
I get that. Yeah.
Okay,
It's still weird
so
though.
it's a little weird, but I think once you think of it as like actually when we think of it in this like kind of object oriented context, it'll make some more sense. So then it goes ahead and the tail after this like tistar is like this thing what we've already seen where we wrap it in agent debug to produce a new Gall agent. But the key thing is the end product. If we leaving aside the agent debug, which we already sort of just know it works,
Hmm.
um, leaving that aside, the end product is this door,
That makes
right?
sense.
Like,
Yes.
and that door has its payload of the bowl, and then it has its context, which is everything before here. So that sort of is what puts all this stuff into like scope, basically.
Okay.
right? And so essentially, at the end of all this, we have a door that has this state face in scope, and the state face is critically, it's the bunt value of state three. It does not have any like other value assigned to it. We say bunt value, we just mean it'll be send three with the default value of whatever an inbox is,
Right, right.
right? So unlike Java and VBA and C++ and Python, there's no idea of a constructor. So once Gall says, give me whatever is in here, Ford goes ahead and gives it to it, and what it gives it is this door. And so now the question is like, what the hell do we do with this door? Right?
Right.
And so what it Gall does then is the next thing is it goes ahead and gets the state from the previous version, or we had already saved it as we said, and then in this new door we got, it calls on load. And also, so what it does actually, if we want to get really technical, is it sets the value of the bowl and then calls the onload arm.
Okay.
So it would actually it would look something like literally internally. Let's say we had like our core was named C, like for this thing, or CS for chat store.
Right.
It would actually look like what it's doing is running onload CS with bowl set. This
Okay.
syntax should make sense, right?
Yes. Yes.
Okay, so we're basically saying call the onload arm on bowl, and actually onload even takes like old bays. So let's pretend that we had our state, like we had that old state bundled up, like old state vase. Let's say we like run. So the first thing we do is in the old agent we run the on save arm, save the whatever it returns as the face old state vase, and then pass that to this thing.
Uh-huh. And so we call that as a gate with the old state as the argument to the
Yes,
gate. Yeah, okay.
exactly. So we kind of seed it with bowl as the value, and then call it with state. And then what does that give us back? It gives us back the quip card and then type of this. Meaning, we already know what the card part is. I don't need to go into that there. Let's focus on the this part. Whatever we do here, we return a new version of our whatever I was calling that thing,
Our
like
door.
chat star agent, our door. We return the new version of our door, but with the state updated.
Okay. Okay.
Okay, so in these things, if we didn't have a thing to like change the updating of the state to make it a valid state three, that's just impossible because the type of door we have requires a state three to be the thing that's like in there in that part of the subject.
Yeah, okay. All right. That makes more I understand better how that works now. That's
Mm-hmm.
good.
Key kind of learning thing there to take away that actually seems like the crux of it for you in terms of on load is that like it's like two separate steps. Create a blank version of the like agent door,
Like the new
right?
state.
Yeah, with like a blank. You meaning we just like call this thing and get it back, but with like we haven't called on load yet, and so it'll be like a blank version, meaning
Oh,
this
I see.
state variable. Well, it'll be like with a bunt value,
Yeah, yeah.
with a bunt value for the state, and then second step is call on load
Okay.
as a constructor, as kind of like an unofficial constructor.
Mhm. So that create the blank version with the bunt value for the state. That's what really does the teaching for me there, because like that makes sense.
Yes.
If it's a bunt
Ex-
value, it can be whatever you want it to be, and then once you call unload, it just has to then nest thereafter. So that's where you get the
yes.
updated version of the. Okay. Yep.
Yes. By the way, we don't have to do it as a bunt value. I could easily do a tis less or a tis fast here and
Okay.
do it as like state three. But the key thing is like that's there's various reasons I might want to do that. But the key thing is that it's some default value
Mhm. Mhm.
that
Mhm.
onload goes ahead and changes. And the third point is that it's like there's nothing magical about this. All we're doing is evaluating all this, and then finally we can kind of parse this a bit. Oh, okay, the thing it returns at the end is this door.
Okay.
We're wrapped in an agent debug, but we've seen how that works, so we can abstract that detail out for now. Onload is basic. Yes, that's exactly correct to say, Pathos.
Yeah.
Um, it's like it's kind of a hacky or maybe like by convention Constructor. Okay, so this is basically how you simulate constructor behavior in Hoon, which doesn't have them. And I think it's totally a fine decision not to have them. I don't think this is like hard, but just if it helps people with the analogy, it's not like a perfect analogy, but it helps you. You can see how Java and Hoon have different ways of achieving the same goal of initializing some like blob of data. Okay, so let's look now at like imports, files, and marks, because that actually goes directly to this topic. So
Okay.
there's a nice segue there, which is for nearly all Gall apps, you want to use some outside libraries, your own types. Static resources like HTML and image files. Actually, no, you can still like do fine with like fast-tar. So I'll leave those in. This was all drastically simplified in the Forward Fusion update, and so now there's only 4 runes. There used to be like more sort of stuff you could do. We have this like fastcat, fastmic. There's all this like chain. Notice how these are fairly complex expressions with like sub runes inside. That's like that's all completely gone now.
Good.
Okay.
Okay.
So they simplified it. You just have this. I need to. There's one thing I want to take a look at though, which is importing. Let me just see something in here now that I kind of just bring that up to my attention. Okay, I'm gonna have to look sometime at how. Oh, that's right, because yeah, the idea was they kind of offloaded all like static resource handling and stuff like that. They offloaded most of it to the new like file server program to serve things like images and other like static resources. Okay, so this is Ford has become like much more about like importing code or some certain types of like text files and things like that.
That is in opposition to doing work.
Yeah, in opposition to handling binary files heavily.
Okay.
There's like less support now for doing random binary file stuff because they've kind of converged more on this idea of like Ford as kind of a code manager.
Okay.
So it'll be a little bit simpler to go with. So if you're like running this lesson on your own, I have these files here. There's more files than we've previously seen because I added another type file and I added a mark file, and also like an example file, an HTML file. So we'll see how we use those. So first one that you'll see in almost all files is FastSep. Import types. When I say import types, everything here is by convention. So you don't have to have like just types in that file. And but the thing that happens when you use FastSep is it imports from SIR. Okay.
Okay.
So it imports from SIR, and by convention, this is like inert code that doesn't sort of do any work, but only handles like declaring types.
But it could,
okay?
Is what you're saying. It could have.
It could.
Okay.
There's no problem with doing that. It just evaluates it as Hoon.
Okay.
All right. And the reason I did 2 different files here is because I wanted to show a couple different patterns.
Yep.
One is I could import it just as Ford example, and then anytime I wanted to do something, it would you would do whatever the name of the thing inside here was, col Ford example.
Yep.
Here I show it I can give it a face, FordX, or I can use tar, which just basically imports everything in it and puts it into the current namespace.
Right. Okay.
Okay. It's pretty common. I would say it's common / fine style for whatever generally like whatever the SIR file is for your current like program, you can like tar that and bring it in.
And if you're bringing in something else, then maybe alias it.
Bringing in something else, yeah, maybe not even maybe. I would like definitely either alias it or use its like name.
Okay.
So here I have like, and I guess the exception is stuff that's like resource where the stuff in it is just so obvious and common and it's just named resource. I sometimes will like just pull that in like that.
Okay.
There's a few things if you just feel like it's going to be really easy for the reader, but in general, it's better to use this other version because like it's just easier for readers to follow and know where your stuff is coming from. One exception, a little bit, is this stuff like do I use where I use some oh I don't use server anymore. So for something like for something that used to get used a lot, like tar server,
Hmm.
people would just bring it in. But with the new static file serving Gall agent, it doesn't get used as much. Okay, so that's fairly straightforward. Same with like fastless, which is um, import something from the lib directory.
And that's
Okay,
more
S
functional things, right?
exactly. Let me see if I can find a kind of. I like giving these concrete examples. So let's do something in lib like chat view is like a good one, and just to show how it gets used.
Hmm.
Um, this is actually a really common setup where you have the lib file for chat view. Crap, this is. You have the lib file for chat view. So annoying. This thing. Are you seeing this like video sharing thing on the top or not?
No.
Oh, okay, cool. So
Oh, is
you
it
have it
popping
like
down on you?
it's popping down
Yeah,
from the
okay.
way to the top.
Okay.
Yeah, yeah. So right here, we import the SIR one right here, and then we just put it into the scope by doing this. So we do this like tiscal, which is basically take SIR and everything in it, and just put it there. And
Okay.
then take the current subject and do that. So what it means is that in our chat view app, what we can go ahead and do is just import the library with fastless, and then we get access to both the functionality and the types.
Okay. And then
Uh,
there's the tis com after that, and that's exposing. Go back to the last file that you wrote.
yeah, the tiscom is basically saying, okay, we're going to go ahead and export this up here, or like make it available.
Yeah.
And now for the rest of this file, I also am just going to put everything insert into scope.
So you can call the faces
So
directly.
I can just call the faces directly,
All right.
meaning basically like the action face. Okay, so the one up here is saying make SIR available to like anyone who like imports this,
Okay.
right? Which means in practice, if we look at like the app chat view, that like any like you can use both the library arms and the types both underneath this view name.
Oh, I get why. Okay, I think I
Here, here's
understand how
here's a
that's
great
working.
example. So here they're like, okay, take view, find the dgest arm in
Yep.
its subject right here, and then find the action arm inside that. And so it does that. But then we'll also see examples, I think, where yeah, exactly. So now here it says, okay, go to view and get the action type. And we're like, oh, there isn't any action type here, but actually there is at the top because we exported SIR as the first thing.
Okay.
Which just as a probably not exciting spoiler, there's an action type defined here in the SIR file.
Very interesting.
Okay, so I'm just kind of trying to get you guys used to, in a code reading sense, to stuff you might see. And the thing you're seeing here, what the kind of library author is trying to achieve in this example, is to um, export the how would I say this? What are they trying to achieve? They're trying to export both functionality and type in like one export. Otherwise, you would be tempted to like maybe write some functionality like this JSON parsing in the type file, and that's just preferred not to do.
All right. I don't know. Well, okay. Why would you be
Yeah,
tempted to do that?
yeah. The reason you'd be tempted to is because otherwise it would be like maybe annoying because then you're like if we went back to our chat view example, um, every time you wanted to like essentially what they want is they're like, look, I know that when I say call view, I want to mean both the library functionality and the types. I don't want to have to write view lib and view sir.
Okay. All right.
Okay, so basically they want to just put essentially, why would you be tempted to? Because you want them both under one name.
I'll accept that.
Yeah. And again, just by convention to keep things straight, it's like preferred to not declare types in the lib file and to not declare like kind of functionality in the sir file.
Here's a dumb
But
question. Why would you
yeah,
declare types in the SIR file at all? Why wouldn't you declare them? Oh, is it so that they're available to other programs?
yeah, absolutely. There's a
Oh,
lot of it's actually so one is so there's two reasons. One is just that it's like I think generally sort of considered good, but you're right that if you had a small app, you absolutely could just put the default. I think would be to put everything in the app file, and then you only start breaking it apart when exactly as you said, if you think other apps might want like access to it, and for some
hmm
reason, for any reason, you want to put it in the SIR file. Otherwise, they have to import your whole agent, which is weird and stupid and not really desirable.
or rewrite your type based on looking at it, and then if you update your
Yeah,
application.
that's so much worse that it shouldn't even be considered. But yeah, that's stupid.
Well, you see where my brain goes.
Yeah. Don't do that. But also, when you're writing apps, like generally, you want to expose the types you use, except for and like even your state should be like kind of using things from your
Like that inbox
y-
store.
exactly. Your state should be using things that you define in your own files.
Okay. Okay.
Um, Okay, so going back now, so import libraries. Again, we've already seen this a lot of times, like with importing default agent that we use here to like make a def alias and then um, like call it.
Why don't they do that?
Um,
Oh, because they have to pass the bowl to it. That's why they don't just alias it as def up there in the import.
yes, that's correct because they need to pass the ball
Okay.
to it. Okay, so and actually default agent sort of is a core. Like if we look at so it's in lib, um, default agent. Like if we look at what it produces at the end of the day, yeah, it produces this wet gate.
Okay.
Okay, so it produces a wet gate, and then from that like wet gate, and then so we're basically just calling that wet gate here, which in turn produces a door, and then we kind of deal with that.
Right. Okay.
Okay, so this stuff is like really straightforward, and there's almost not much more to say about it, except that Gall is calling out to Ford to handle all of this when it makes a new file. Um, Fastis, which I always confuse with tisfast. For a while, I would always write fastis instead, and then keep getting errors and not know why. But anyway, it's like
Easy to do.
I don't know. For some reason, it just looks more normal to me. So yeah, what this goes ahead and does is like this is basically when you want to import some hoon from somewhere and evaluate it. Okay,
Okay.
so I said lib number to words, so I'm going to go ahead and just look at this. Like, wait, okay, yeah, this is So I'm saying go ahead and import this lib number to words, which actually is just in the normal lib directory. Okay, I literally just chose a random file that has some functionality for taking numbers and making them words.
Oh, that's cool.
Okay, yeah, it's moderately cool, I guess. All I do here is I'm based at the end of the day, this is basically just defining a face for this. So basically, evaluate all this hoon and give it a face. What's the difference between this, and this stuff up
Yeah.
here?
What is
The
it?
difference. Okay, what do you think? The difference is not exciting.
Okay, hold on.
So you're absolutely right that up here, I'm going ahead and like defining faces for hoon files that I evaluate.
And then down there, you're evaluating the file.
Uh huh. So what do you
I
kind of
don't.
notice that's different about like this line versus like the other
You
lines?
have to specify that it's in lib. You're
Yes. And not only do you have to, you have the option to. So
okay. It can
fastest,
go from
what is it?
anywhere. You could have a gen in
Exactly.
there.
Absolutely. So, or even just a random directory you made or something. So
Oh,
it's
okay.
basically them leaving away in Ford to handle like arbitrary directories.
Okay. Okay.
Okay. And
So there's
about and
nothing else
evaluate.
different about it then.
No. So the way to think of of fastest is we're leaving a way to generate like to sort of look for hoon in any directory, evaluate it, and give it a face.
That's kind of cool. All right.
Yeah, so it's there. I don't think I've used it since it's been here. Just because everything is pretty much handled by the lib and sir cases because functionality and types are pretty much everything. In fact, for this contrived example, I couldn't even think of a way to use it, so I just imported something from lib. Like, yeah.
Okay.
Um, the last one actually makes more sense. So the last one is actually using marks to open, random data and do stuff with it. Okay. So do you know about like marks yet?
I don't really understand what they are. I'm aware of
Okay.
them, but I don't know what they are.
Okay. So they're pretty straightforward. They're basically just cores that define how you want to handle different types of data. They let you give a name to like a type of data and then define how you can convert to it and how you can convert from it. Okay. So what that means is, let's say you know that you're going to have HTML files and you want to give a way to like convert those to like text, or even maybe like, very, potentially lines of text, maybe like a list of chords.
S-
So you're going to have some like HTML files and you want to have a way to like, convert them to like lists of chords maybe, right?
Okay.
Or convert maybe like another very possible one is you want to have a way to convert from like nouns or other things into HTML files, or what you define HTML files as. But also, that your HTML files are going to need to get served up by file servers, and you want to have a way to kind of convert them into the format that like a web client needs.
Okay. That makes sense.
Okay, and so this is just like in Unix, this is all done in like kind of weird ways, or in Windows or Mac, they have these like special file type things. And in Urbit, it's done just by like writing explicit programs that say how to make various conversions. Okay?
Okay. It
So
kind of blows my
some
mind.
I'll give some I'll give some examples. It's like it's honestly like not even that exciting, which is kind of nice. It's very like basic transformations with clear rules. First of all, like, why do we want them? One reason is if we're going to import files with Ford, we need to have kind of a way that once Ford takes it, we can kind of specify. All right, at the end of the day, I'm going to have some face assigned to this file, and I need to know what's in that face. I need to have a way to like give it a strong type.
Okay.
So I have this like random data in a file, and I need a way to like turn that random data into like something where my program knows what it is.
Okay.
Okay. The other really, really common case is sending data to Gall apps, meaning you're going to send some data into a Gall app. If you give it a mark, then your Gall app can have a way to know exactly what it has coming. If it matches certain transformation on it.
So is that like how the weather application takes in information from whatever service it read, like dark sky or whatever it is, and it goes, this is going to come in this mark, and then you have a way of handling.
Ah, that's a really good question. I actually think it might just I haven't looked at weather in a long time. Or like how it even does anything. Um, so it has request dark sky. So it makes that request. If I look for a request, I think I even looked at this file when I was learning kind of. Right, it makes request HTTP is like it makes that dark sky request, and then if I look for rec, oh, okay, okay. So what it does is it passes a request to the iris vein, which makes outgoing HTTP calls,
Right?
and so and so then it names its wire here, and its wire is basically just the current time. And so we're almost certainly then going to see like an on arvo where it like you right, it waits for like an HTTP response as the sign coming back in.
Yeah.
Um, and then if it gets that, it kind of goes ahead and processes it. So the answer here is that we're not using marks. If we wanted to look at a place where we do explicitly use marks, it will actually here. Here's one, which is where the mark is JSON, and so then it's able to know that it's in JSON format and do and like extract it as JSON and then do parsing to it.
That's like when you
Or
punch in your address or whatever. Not address, but your coordinates, right? That would be the JSON that it
yes,
gets.
yes,
Okay.
exactly. That would be the JSON coming in. Another example would be like I mean I use this setup really often is I'm waiting for a picky action mark right here, and if I get one, then I know that I can use my action to parse it. And so what it does here is it looks for my mark both for JSON here and for picky action here. It looks up that mark, and before I do anything with it, it makes sure that it even can translate the stuff in the vase using this mark. Otherwise, it'll throw an error. It
Okay.
being being Gall.
And where is that? Where is the mark defined for picky?
Yes. So now we get to like the good part. All marks are defined in the same place. Okay. So we had lib and sir, and there's one other directory, which is
Mar.
mar. And mar has all the marks. There's
Okay.
this like syntax thing where if you call your mark something with like hep, like picky action, it will find that if you make a thing in mar called picky action dot but it also will look for, or if I have something like file server action, it'll also look for it under the directory file server and then action dot.
Right. I did that for the thing that I made with Rizrak, but I didn't really know
Yep,
what I was doing.
it's yeah. It's super common. Okay,
Okay.
and basically, if we go back to here, so that's what we're doing. I'll give you like an exact example of this in terms of opening an HTML file. Okay, so
Okay.
we're gonna look at some stuff. So the way that the syntax works, if I go to forward example, is you first give the face that you're going to assign the result to, then use this is the mark that I want, and this is the file.
Okay.
Okay, and what it does, forward always uses the extension as kind of let's call it like the first mark. Okay, so it takes like the data in there, and it parses it, and then it runs it through that mark to start with. Okay, so when I say runs it through that mark, we should look. So it says HTML. That means to figure out what's happening here, we can actually open up HTML.hoon and we can actually look at what happens right here, which is um, if you grab it and it's like just a noun coming in,
Mm-hmm.
which it will be when it parses it, it runs this on it. It casts it to this.
Make to the chord.
Yep,
Yes.
exactly. So casting and running a gate under are the same thing. So it basically casts it to a chord, which is running the kind of cast to chord function,
Okay.
right? Which is the same if I do like like that, but it's actually like a function. Um, and now here we say that we want it as like the mime mark, and so it opens it. It first casts it to runs the HTML mark on the data, and then it goes ahead and finds the mime mark and runs it on it. And we're going to look at like what that there's a sort of a search process there, and we're going to look at how that works.
Okay.
Because if we look at the mime mark, it actually doesn't have HTML anywhere in here in this file. It doesn't have any way to do like HTML. So we'll look at like what this means. Okay. Now, if we look at HTML.hoon, we'll see that it has grow arms and grab arms. And all this means is grow is how do I go from HTML to a different mark, and grab is how do I go from a different mark to HTML.
Okay. Okay.
Okay? So when we first read this in, it has a noun, and so it's going to run like the grab. I'm pretty sure on this. It's going to run the grab mark on it and try to convert it to a chord.
Okay.
Okay. Um, Now, grow is I have HTML. How do I make these other things? So the order of searching is that um, this rune here, it first Tistar or sorry Fastar, it first looks for a grow arm from the original mark to the new mark. If that's not present, it looks for a grab arm, and we can actually verify this. Um, well, one way we can verify this is that um, I'll show some examples in a sec, but mime doesn't have any grab arm from HTML.
Okay. So you have to
Okay.
grow it into it.
Yes. So what it does, and it actually searches for grow first, and I confirmed this through experimenting and asking about it. But it actually will first go here. It says, "Oh, I'm trying to get mime," and the name, and by the way, the name of the arms here inside here has to match like this exactly.
Okay.
Okay. So it says, "Okay, cool. I do have a grow arm for this mark from HTML. So I'm gonna go ahead and grow." And notice this is a door. And so this is actually like an interesting hint right here, which is that if we have HTML, it's going to be as a chord.
Okay, that's one thing I was going to ask is like the grab when we call a chord HTML, it just means that we're handling what would be HTML as a chord in who and whenever we refer to it this way. Is that right?
Yes,
Okay.
exactly.
That's kind of weird to
Exactly.
me, but for
It's
no
it's basically
particular reason.
just think of it as we basically like right here we just we get to define, and I'm going to show more clear examples of this. We just get to define what it means for something to be HTML.
Okay.
And we're saying that what it means for something to be HTML is that it's a chord.
Okay. And that's just to give us all of the text of the HTML for later parsing if we needed to.
Correct. There's lots, and maybe to serve it up to clients who ask
Mhm.
for it.
Mhm.
Okay. And in fact, we're going to see that right here, which is okay to convert it to like a mime, and this is how a mime mark looks or what its type is. Actually, we can look at this. It's kind of interesting. So one thing I'll often do to figure out what a mark does is I just look at like, okay, what does it do when it like grabs it? Okay. Where's the? This is actually. Oh, right, right, right. Okay, this is actually really interesting. So we should look at it. So when I'm trying to figure out what a like HTML is, I go and look at its grab arm, and I'm like, oh, okay. HTML is like a chord,
Yep.
right? And we even see that. We also see that in the door. Usually, I'll look at the grab arm. Um, for this one, it says it is a mime, and mime isn't referred to anywhere here.
Right.
So that means I'm going to need to find it in the standard library.
Oh, interesting. Yeah,
So
so
that
that would
means
be
it's
like
gonna
writing chord there, like
exactly.
full
So it
out.
means exactly. So it means it's gonna be in hoon.hoon or zoo. So we could look for mime, and we wait, failing search mime, and then I'll have to also look for like this no mime. So that means it's like probably in zoos or in Arbo. Mime. Okay, that's mimes. Mime. So it's this P is mite and Q is ox. Ox are basically bites. Um, and so it says basically if you have a noun, just try to cast it like as something like this, where the head is like a mite and the tail is bites.
What is what is a mime type? Like just in
So yeah,
computer
what is
science?
it? What is it? Yeah, it's all it is a like a thing that is it's like a certain name. There's like all these names by convention that are established by various standards for like various types of binary data.
Okay.
And also so it's like the name of it, like this application exurb unknown, or I don't want him, I want HTML. So this kind of name like text HTML,
Yeah.
and then the number of bytes, and then the binary content itself.
The number of bytes that are in the binary content is that the
Exactly. So it's basically a way. It's almost like so Urbit has its own kind of like marks, and it's like MIME types are like a way of marking data that like web clients know how to use.
okay. Okay.
So if they get a MIME type like that's like PNG or text or something, they'll be like, okay, what's the name of this? How many bytes does it have? And then here's the binary data. So basically, so that it can handle the binary data.
Okay, that makes sense.
Okay, so basically, all we're trying to do here is we're like, okay, if I have HTML, how can I put it into like Urbit's version of a MIME
Hmm.
type, which then Urbit translates to a normal MIME type, or the functions that handle this kind of stuff translate to a normal MIME type.
Okay.
Okay, so we have that here. It's like, and all it does is if it wants a MIME, it has it sets the value of the door to like itself, right? And then it says met3 is basically count how many um, things of size 2 to the third are there, meaning like a byte, because 2 to the third is 8.
Hmm. Okay.
Right. Essentially, met3 for any kind of data is just like, like, it needs to be like a noun. So if I I wonder if I just like, so that's 1 byte. Oh, 2. So basically, it's like how many bytes are in the number 9, 1, how many bytes are in 999, like 2.
Interesting. Okay.
So it's like counting those, and then it puts text HTML right there. Okay.
How does it get to the? Well, we don't need to worry about it. Okay, I follow what you're
Uh,
saying.
Let me do one thing here real quick, which is I actually want to go ahead and commit my code and then run start because I do have something set up here to do like various pokes. So now we can kind of get a little bit into like what poking is. And poking is you send a message with some mark,
Hmm.
and then your on poke function needs to handle the mark and deal with whatever's in the vase based on that.
Okay.
So if the simplest form of it is you don't make any kind of like definitions, all you do is you just say, all right, it's going to be a noun.
Right, which is lazy.
Yeah, and you just yeah, because you don't get any real guarantees. Although
Right.
you essentially, well, it makes you handle the guarantees in your application logic, right? And
Makes me.
I'm still getting the guarantee here of I'm going to check what's in the vase.
Oh, I see. Yeah, yeah. Okay.
So here I actually say mark example. So all I said here was I want it to be a noun. It's going to be mark example. If I pass something it didn't know about, like just a random number, it's actually going to say there's an unexpected poke with that mark.
That's a what less default behavior. Is that right?
Yes, that's what less default behavior is. It
Okay.
just passes. Yeah, exactly. Good catch. So all I'm doing here is I'm like, okay, check the mark, see if it's a noun, and then switch on like the value inside the base. So this is like very like kind of dumb basic behavior. I don't really use it anymore, especially with like debug being there, but you can do it. And it's not bad for this kind of app where we just want to demonstrate like just calling things in here. And so I print out HTML as HTML and then HTML as mine. So it read this like file that I had here
Yeah.
and it just prints out remember as we said HTML as a chord. So it looks like that.
Oh, yeah, yeah. Okay.
And it even has a new line at the end right here. And then here we have exactly the same chord at the end. We have the number of bytes, and we have this like path at the front.
Oh, but it doesn't have to convert the bytes into like binary.
No, no, it's totally fine. Like just like here, like doing them as like still like a chord.
Okay. Okay.
Okay. Um, and so it has that. Um, and so we checked like the results there. Let's look at a custom mark. And the thing I want to show with a custom mark is that this is doing a reasonable thing here of like adding a path on, adding the number of bytes, and then putting the content.
Yep.
And what I'm going to show is you don't have to do reasonable things. You can do whatever you want. Okay.
Good. I'm not good at
Um,
reasonable things.
yeah. So what I did here is I just made my own like marks for Ford example. This one called like name, and I said here's HTML as name. Read the same HTML file and then slap the name mark on it. Okay,
Okay.
so in fact, I'm going to show the example first before we do anything, which is custom mark example. Um, Custom mark example, and this one says for so. I have on my. I'll just show you before we do anything else here. What I want to show you is that I have this like name type that I made in Sir. Okay,
Okay.
so it's like a name is a first is a chord and a last is a chord.
Sure.
Pretty straightforward. Okay, and I don't even need to like import it to do anything here. Although we did import like the library at the very top, or the Sir at the very top. So what it does is it makes when I run this custom mark example, it prints out something where the first is set to HTML and the last is set to the value of the HTML.
Naturally.
Yeah, I mean, I could do any. I'm just doing really just random stuff here, right?
Yeah.
It's completely arbitrary behavior. So we said that first, when you get to do a mark, it looks for a grow arm, but it's as is going to be almost always the case when you make your own marks. Um, HTML has no concept of what a name a Ford example name is,
So
right?
you gotta do
So
you
at
a
first,
grab.
you got to do it. You got to do a grab of your own.
Okay.
Okay. Now let me just think backwards, which is like mime all like mime didn't do a grab because when they made this built-in type HTML, they're like, okay, I'm frequently going to want to go to mimes, or maybe mime existed first. So because the conversion there is HTML like to mime, HTML can go ahead and write it because it's the one being like read in as a file. But because Ford example name isn't the one being read in as a file, the kind of customization thing is going to be writing a grab. You don't have to remember that. All you really have to think of is what do I have and what do I need, and then it'll be pretty clear whether you need a grow or a grab.
Would you say that it kind of also has to do with whether or not the things were written by the default system?
Yes, and so what I was getting at is um, you could go make your own file type and give it like its own grab, and then it will slap this mark on whatever noun it parses in. Okay, so you can cast a noun. I should have actually maybe should have even written that for this lesson. HTML here is arbitrary. Whatever the last thing is here will be the extension and will be the mark it uses. So I could just like have named this example, this thing like example dot like timlook, and then made a mark called timlook with a grab arm that takes nouns to something.
Okay. Okay.
Does that make sense?
Yeah.
So, but you're right that like it has a little bit. It does have something to do with what like what's built in. Like HTML is built in, so it's there. But you could absolutely kind of make your own file type, like a rabsef file type.
Right. Okay.
And unlike like file types in well, I guess Unix they can be as long as you want, but in Windows or something, the file types can be as long as you want, like the names. Like
Yeah.
there's some long names here for marks, like drum put, ETH watcher poke, helm high, and you could use any of those as long as they have a noun conversion.
Okay.
Okay. Um, okay, so we said that we have this like what I wanted to show though is that for HTML as name it says read it as HTML, then slap the Ford example name on, which means it's going to look for um, wait, it's going to look for in Ford example in name how it like its grab arm for noun or for HTML. Sorry, for HTML. So for HTML, its grab arm is um,
Oh, it's just stupid.
yeah,
Okay.
it's basically. I notice how it can be a gate like this,
Yeah. That makes sense
right?
too,
So
because you'd want to be able to take in something and then you slam a gate on whatever you're working
exactly,
with.
and so you're responsible for knowing that like HTML would be in this chord form. If it was MIME, you would want to make sure you were like handling that like three-part cell.
That's kind of what I meant by like the built-ins versus ones that you build on your own, right? Like if it's built in, it seems to make sense to put the onus on the new type that's being built to do the work.
Yes, exactly. And not even, yeah, you put the onus on it, and also they can just go read your source code, know what you look like, and then
Right.
handle that. Yep, absolutely. And so I handle it in this weird way, but it does work. And it's not
Yeah, no,
so weird.
it's
It's not
cool.
even, to be honest, it's not even that different from like mime, where you're like doing this calculation, putting a path at the beginning, and then putting the content at the end, like I am here.
Hmm.
Whereas if I want to like if I want to take a Ford example and it started as a noun, then it would do this, where it puts the first name as noun and then the last as the data. So
Okay.
this is if yeah, if the thing I had was a noun.
Okay.
Um, so those are there's honestly most of the time what you're going to be doing with marks is like pretty basic stuff in terms of like maybe you're reading a file in from clay and you have to like see what this file like does, what kind of type it is once its mark is applied. So for example, if I'm reading like a text file like with a text extension,
Yeah.
that would be the case where then I just go to like the like text.hoon. I'm like, okay, what does it grab it as? And I'm like, okay, if it's a noun coming in, it like casts it as a Wayne,
Okay.
which is a list of chords.
Okay. For each line, I imagine.
Exactly. So it
Okay.
actually does. So the text mark basically does the work for you of separating lines into a list.
Oh, that's interesting. Okay.
Yeah, and that's actually a good way to think about it. So I'm like, okay, I'm applying this mark. What does that actually mean in practice?
And this is in text. Mar. Why is it
Yeah.
in Hoon? Oh no, that's reversed. The like line two has the file extension or the place where it
Oh,
lives.
Hoon text mark. Yeah, I don't know what's going on there.
Okay.
I don't know why they were. That's all. It should be mar slash text tune.
Yeah, yeah. Okay. I was
Let me
just
see
getting a
if
little
other.
confused by that.
Wait, all of them have that. There's probably some weird legacy reason that I don't know why they're doing that.
But okay.
Yeah. Okay. Final thing after that is there definitely are cases where you want to do imports in the dojo, like you're sanity testing something and you need to import a library. Like for example, let's say you want to import default agent, or even a really common one actually that also I have the default agent example here.
Hmm.
Um, is if you want to import like a kind of custom like type. So I'll just set R equal to what I'm trying to do here is I'm trying to import the resource type. Okay, so I have Sir, and resource is like entity, which is a ship, and then name, which is a term. Okay,
What is
and so what
that?
I
Is that for like calling one of their agents or something?
no, resource is usually used if you have like a let's say like a group name. So it'll be like the host of the group is entity,
Oh, and then the
and
name of the
then
group.
name is the group is like the term for the name of the
Okay.
group. Okay, so that it's used really often for like exactly that, and in fact, it's probably even used in group.hoon. Yeah, it is. So groups are like in like the group store is like a map of resources to group types. So resource being the ship and the name of the group, and then group being the actual data about it.
Okay.
So all I'm showing here is
Janitor.
let's yeah, exactly. So I'm saying here like let's say I wanted to like get this into my environment in the dojo just for maybe some sanity checks or like testing purposes. I can use this build file command in the dojo. Okay, and what build file does? So yeah, sorry, not build resource, build file is it says you can go ahead, give some Hoon file, and it will evaluate it using Ford and attach it to the face that you gave here.
Can't you just
Okay.
import using the Ford runes?
Pretty sure you cannot. They actually won't even let me type them, or it'll let me type it, but then it's going to be like weird. Like, how would that even look? Like resource. I wonder if it. Well, actually, let me see.
I'm
I
pretty
haven't
sure
tried.
I've done that before. Well, with the
All right.
library at least. I don't know
Yeah,
about the
yeah,
other
yeah.
things.
No, no, no. You might be like totally right. So let me just see if I can do a resource like yeah, I can't find or no, it should be resource probably. Yeah. Yeah, I can't find it, whereas my awesome R it should be able to. Let me see. Yep, it works. Yeah, so this is what you do if you want to use one of these in the dojo.
Throw a dot for me.
I,
I want to see what your
what?
subject is.
And R, it's like I've cleaned my subject out. Oh no, I have the R in there, and so notice R is like that. It's like actually the entire contents of that thing. So
Yeah,
we can actually go back up here, and it should just give us like the contents of the hoon as a noun. Yeah, give us
yeah.
the. And if we look at resource, it has one, two. Yeah, it has three arms. So that's what it's giving us here. It has three arms. Let's check out those. Let's probably break everything. Like if I did like, oh, it's not gonna. It doesn't want me to do this. There we go. There's all my three arms.
Very cool.
So, yeah. Um. So that's like this. The way this comes up is, let's say you're writing your own program, and you have some part of your code that like kind of does something with I don't know. There's a lot of reasons. I just want to find something with call. Um, yeah, like I have something here with like call group. Let's say I just want to like test this and just paste this whole like kind of gate into the dojo
Yeah.
and then test it, but I don't have group in my environment. What I would go ahead and do is I would just do group build build file slash sir slash group slash him. Okay, and so this would basically then let me cut and paste this and it would work. Because I have this thing up here, and if I don't do this build file here, this line, it'll choke because it doesn't know what a group is.
And then you can remove it the same way,
Correct.
but just like unpinning that face, effectively. Yeah.
Exactly.
Okay. Okay.
So just kind of a helpful thing to know there. I'm going to put up the exercises after the same way I did last time. Probably on similar lines with some code modification within here. Do you have any questions?
I have one kind of stupid question. So
Mm-hmm.
suppose you wanted to write a browser for the web for landscape.
Mm-hmm.
So like within landscape, you'd have another browser. That
Mm-hmm.
would part of that task would be like making that browser handle all of the different types of files that it would come across in the wild. So it would handle MIME types that it's getting from other servers that are sending in
Yeah.
information and then turn those into HTML. Is that right?
Yeah, that's about
Or
right. So
render them in some
basically,
way.
so what you would do is you would probably you definitely would use Iris to make like external calls
Hmm.
to resources, and then Iris would send you like it would basically give you the HTTP responses there, and then you would be responsible for handling them. And
Okay.
the HTTP responses would include, what their MIME types are, other stuff like that, and then you would figure out how to handle it.
And you
I'm
could
not sure
do.
if I.
Go ahead.
Mm-hmm. No, go.
You could do it like the incoming data. You could have something like the forward example name.hoon type for HTML that's coming in, so you don't have to handle it in the same way that maybe other browsers expect you to handle it. Does that make
Yeah,
sense?
that's about right. Yeah.
Okay.
But
You might not want to.
yeah,
I'm just trying to understand
yeah. You
arbitrary
could you
types.
could do this. Yeah, the main use for marks that you should keep in mind is really just this like kind of basic case of poking, and this secondary case of like reading stuff from clay
Okay.
with
Okay.
forward. That's really like. Other than that, it just doesn't isn't going to come up a lot, and there's other ways you're going to be handling data.
What about writing to clay?
Yeah, also writing to clay,
Okay.
reading it. Any interaction with clay uses marks.
Okay.
Yeah.
Very interesting.
Yeah. So this after this lesson, things are gonna go, especially with poke and watch. Things are gonna speed up a lot in the next four lessons, and it's just It's just going to be tons of examples, in not a hard way, tons of examples, and kind of it's going to feel like lots of stuff is happening,
Okay.
like sort of real program stuff. This was the last like kind of this stuff is annoying, and you just have to kind of like work through some examples to see what it is. Like it's the last like Urbit weird stuff example. Like in terms of on load on saves, a lot of like Urbit weird stuff. This one is like weird stuff with marks, and everything after this is just for the next 4 lessons is just super practical. I have this information coming in. How do I like deal with it? I want to send information out to the outside world. It's just all this like stuff is flying around. How do I deal with it?
I actually do have one other question for you. If you scroll up in our chat and find the homework that I posted just a little bit ago, that first link, the one above that one.
Mm-hmm.
So we were reading the cards, and I don't know that I read them correctly.
Ah, I see, I see.
So I think that's right. We're disconnecting from reading whatever's coming in or from listening on weather.
yeah, so essentially they're like deprecating it. They're just they're not gonna let that thing be there anymore.
Okay, and then the next one I thought was really interesting, but I think I understand what was wrong about my thinking. Like the chat view disconnects from listening on chat and starts connecting by listening on chat view. And I was like, "Oh, but chat view isn't where you're actually seeing chat." But that doesn't those two things aren't the same thing. Listening and displaying the application are different functions. So chat is listening on chat view to get some information and then serving the chat application there. Is that right?
Yeah, and here it's like it's basically moved to whenever you see file server, you're serving like static files, and we'll see that in a future lesson. And so they've basically moved their model to basically like the way they handle it now is when you go to that chat URL, the SIG chat, it just goes ahead and serves this directory app landscape, and that'll be static files like JavaScript files. And then the way those communicate back with your ship is there's like
Talking to
built
chat
in
view.
yeah, and there well no actually now there's like built-in air support. I actually need to see why they're even calling chat view now, because there's built-in support for basically sending like JavaScript pokes to air, and air routes those to the right application in
Oh.
Gall.
Oh, is
Okay.
that what they were talking about by like the single file landscape or whatever that was being advertised a while back as part of the OTA?
Yeah, that was when they made this change.
Okay, okay.
They did a few things. They made that change, and then they did this file server change where what it used to be is like all of this stuff for serving files you would handle manually, and it
Uh,
looked kind of something like this, where you would start with a forward runes to import the file's bytes. Okay,
right.
so you would start with forward runes to import the file's bytes, and then in your like HTTP handle HTTP request. It would be this one, poke handle HTTP request. It would look something like this. Let me just go down. Yeah, it would look basically like this, and you would just do all this logic to see what kind of thing it was,
Right.
and then pass back the bytes of that thing.
Okay.
That's all completely gone now because basically they were like, this is stupid. Everyone's doing exactly the same pattern. And they just abstracted that logic of expose a directory and serve all the bytes of its files statically with MIME types. They just extracted that to file server agent.
Okay. Okay.
Yeah, so reading the file server agent is an interesting exercise, and it's likely what I'll do when we get to that part. But yeah, that's why they're kind of going around and disconnecting all this stuff. I actually want to see on. So you're saying this was in chat view when you were looking at the final.
Mhm. Mhm.
One sec. Okay. Usually, what I look at, yes, they connect chat view. So if you want to kind of figure out, this is a preview of HTTP, but if you want to figure out what's happening, you're correct that you want to like look at the on init because that tells us the state they put any new user into. Um, and then we go here because you can't guarantee onload will ever run. Does that make sense?
Yeah.
Right, because like maybe this is the final version of your app. It never gets upgraded. So if you want to see something they're always doing on startup, you look at on init.
Makes
So we
sense.
know that on startup. So we know that on startup they connected to chat view, and then we can always look in on poke and handle HTTP request. And so then we would go to like we see that it kind of does some like ceremony up here. We'll look later at what that stuff does, but we know we're going to end up here. It takes the payload, and we want to look at like what it does. So if site URL matches, so first it like parses the URL, then it gets the site, and it says if it's chat view paginate, then it like does all this stuff. It like tisfasses a lot of variables like a start, end, and path, and then does an envelope scribe based on those. So we can already view. Okay, so we're like, it's this special thing that chat view makes available if you want to get the envelopes from a start envelope to an end envelope. I haven't looked at chat view enough to see exactly why they set that up, but basically it's like this custom. They have all the rest of the behavior is kind of handled normally and mostly just going to be handled with pokes to chat view,
Yeah.
right? So they don't need to do it, but they have this like special. Basically, whenever you have like one of these endpoints, it's like a special dynamic endpoint. I'm not sure why they don't do it as a poke, to be honest, because you can easily pass HTTP information as a poke. So I would have to ask them. I don't know why they do this, but most stuff like this is handled as pokes now.
This is like saying that you could go to some URL /1/10 and it would show you the
Yes, yes.
okay, weird.
It's basically if you've used like called like third party APIs, it's basically like a sort of third part or API that the front end JavaScript can call with some parameters.
Okay. Okay.
The thing I don't get is why they're doing it in this form and not in the form of pokes. Because I would implement this as like just pokes. And the answer might just be legacy reasons that they just never changed it, or maybe there's
Mhm.
some reason I'm not thinking of. But the usual way to do this now would be you have some kind of chat view action that has those parameters. You poke the chat view app with it from JavaScript, and Air translates that into like a poke, and then uses that mark to make sure it's correctly typed.
Okay.
Okay, and that's what we're going to see in our applications. But you will learn enough to be able to understand this and like implement it. It's not super hard. Like the thing you imagined of it having those slashes with parameters is like exactly right.
Yeah, I can almost read what's going on there. Like that one's
Yeah,
closer to what I can understand than than a lot of stuff.
I mean you're understanding like 80-90% of it now. Like nothing that crazy goes on in any of these apps, with a few exceptions. But most of these like user ones are just a lot of like logic glued together, and so the hard part is just kind of following it.
Mhm.
Which is
Mhm.
that's the case for reading anybody's code, like even your own.
For sure.
Like the hard part is like following it through. All right. Well, do you have anything else here?
No, I think that's it.
Okay. Like it seems like the homework was productive, so I'm gonna try to keep it on those lines where there are a lot of like things where you have to interact with existing stuff because that seems to like help a lot and bring up good questions.
Yeah.
But yeah, thanks a lot. It was good, and let's see where it goes. See everyone on Tuesday.
All right. Cool, man. Thanks.
Nice. All right.